Today we're going to be talking about number relationships. This is a review of fact families and place value concepts. Fact families and place value concepts are things that you've learned a long time ago. They're things that you may have learned so long ago that they're almost automatic now. But we're going to ask you to think through these again so that we can extend and apply them a little differently. When we talk about fact families always involve three numbers. When we are looking at multiplication and division fact families, that means that you are going to be taking the three numbers, you're going to use one operation and an equal sign to create true statements. Like, for instance, if I am looking at the numbers 4, 5, and 20. What are some true statements that I can make using one operation and an equal sign using 4, 5, and 20? Well, I could say 4 times 5 is equal to 20. Or I could say 5 times 4 is equal to 20. In both of those, we are using one operation, which is multiplication, the equal sign, and the three numbers to come up with true statements. Well, there are other statements we could make using either multiplication or division and an equal sign. We could say 20 divided by 5 is equal to 4. Or we could say 20 divided by 4 is equal to 5. These four statements are called a fact family. They are using the same three numbers. They are using the operation of multiplication or division and an equal sign. And they are making true statements. So these are fact families for multiplication and division of 4, 5, and 20. Another concept from your past that you may remember are dealing with powers of 10. Now, before we get into the multiplication and division by powers of 10, let's take a look at the numbers 1,110. What do these three numbers have in common? Well, these three numbers are all powers of 10. So, for instance, if I take a look at 10, 10 is a 10 to the first power. If I take a look at 100, 100 is 10 to the second power. If I take a look at 1,000, 1,000 is the same as 10 to the third power. What about the numbers 1/10? 1/100th, and 1/1000th. What do you notice about these numbers? Well, they appear to be using the same thing as the powers of 10 that we just looked at, but the powers of 10 are in the denominator. That means that they are reciprocals of our powers of 10 that we just looked at. But in the world of math, when you have the reciprocal of a number, there is a way that you can write it that is not fraction form, and that is using a negative power. So 1 over 10 would be the same as 10 to the negative 1. 1 over 100 would be the same as 10 to a negative 2. 1 over 1,000 would be the same as 10 to a negative 3. By making the powers negative, we have moved the powers of 10 into the denominator. In other words, we've taken the reciprocal of the powers of 10. But wait a minute. What is the connection between these powers of 10 and the place value system? Think about it. We have thousands, we have tens. Oh, sorry. Go back. Let's fix that. We have hundreds. That's what I get for looking ahead. We have hundreds. And we have tens. What is the one we're missing? Well, that would be the ones. Well, what power always gives you a result of 1? Well, that's anything raised to the 0 power. So we are still looking at a power of 10. 10 to the 0 power, or the ones place. Thousands, hundreds, tens, ones, these are our place values. What about the next set of numbers? What is 10 to a negative 1? Well, we've got 1 over 10. That's going to be tenths. 1 over 100 is hundredths. 1 over 1,000 is thousandths. Again, we're looking at place values. So any power of 10 that we take not only is a power of 10, but it can also represent a place value. Our place value system is based in powers of 10. The reason why this is significant is because when we are multiplying or dividing by powers of 10, we can actually do a shortcut. Each power of 10 represents one shift in place value. So if I am multiplying by 10, multiplying by 10 means that I am getting larger values. But I'm getting larger values by one place value location. So 52 times 10. I'm going to take the 52, the digits 5 and 2, and instead of having them in the tens place and the ones place, I am going to move them by one place value and have them in the hundreds place and the tens place, leaving a 0 in the ones place. So 3.7 times 10. Multiplying by 10 means I'm shifting my digits by one place value. Each place value is increased by a multiple of 10, one multiplication of 10. So when I multiply by 10, the 3, which was in the ones, will now go to the tens. The 7, which was in the tenths, will now go to the ones, 37. So that means for the next problem, 9 will shift to the ones, 8 is in the tenths, 8 is in the hundredths, and 5 would be in the thousandths. We shifted by one place value because we were multiplying by 10. What happens when you multiply by 100? Well, multiplying by 100 means that you are multiplying by 10 to the second. That's two place values. So that means the 7 will shift 2 place values. So instead of being in the ones, it needs to be in the hundreds place. If I shift by 2 place values, I'm going to be shifting so that I have 2 in the hundreds place, 9 in the tens place, 4 in the ones place, and 7 in the tenths place. Everything shifted 2 place values because we're multiplying by 10 to the second power. 6.3. Again, we're going to shift. 6 will go to the hundreds, 3 to the tens. We'll have a 0 in the ones place. So when we're multiplying by powers of 10, we are shifting our place value by the power of the 10. But what happens when you divide by a power of 10? Well, if you divide by a power of 10, remember dividing by a power of 10 is the same as multiplying by a negative power. So if I am dividing by 10, it would be the same as multiplying by 10 to a negative 1 power. That means we're going to be shifting our place values, but we're doing it in the opposite direction. We're moving towards those reciprocal values. So 52, I will be taking the 5 and moving it to the ones place, and the 2 will move to the tenths place. 3.7. Again, we're going to shift by 1 place value, but we're doing it towards those reciprocal values. So the 3 will go to the tenths place. The 7 will go to the hundredths place. Now, I prefer to put a 0 when I have a decimal, so I can make sure I clearly see there's a decimal there. That means when I have 0.9885, I'm going to shift by 1 decimal place, 1 place value. So 0.9885 will each shift 1 place value in the reciprocal direction. So 750 divided by 100. Well, 100 is 10 to the power 2, but we're dividing by 10 to the power 2. So we're moving 2 place values in the reciprocal direction. That means that our 7 goes to the ones place, and our 5 is going to go to the tenths place. 2.947 divided by 100. That means that our 2 is going to end up having to go to the hundredths place. And again, 6.3 divided by 100, we are shifting by 2 place values. That means that I will have 0.063 because I shifted towards the reciprocals. Now, you may have learned this in elementary school by actually moving the decimal place. You're not actually moving the decimal place, you're actually changing the place value system because you are multiplying or dividing by a power of 10. But it is a shortcut. So if I think about 52, if I'm multiplying by 10, I would move my decimal 1 place back. That's where I'm getting my 520. So 3.7, I'm moving 1 decimal place back. That's where I'm getting my 37. This is the shortcut you probably were taught. 0.9885, I am moving my decimal one place back, 9.885. 7, well, 7 is multiplied by 100, that's 10 to the power 2. So my decimal would have to move 2 places back. So I'd have to fill in with zeros to make my 700. Multiplying by 100, that's multiplying by 10 to the power 2. I would be moving 2 places back. This is probably the way your elementary school teacher taught it to you. 6.3 times 100, I'm multiplying by 10 to the power 2, so I'm moving 2 decimal places back. Okay, how does that change when we're looking at division? Well, when we're looking at division, instead of moving back, we move our decimal forward using the shortcut. So if I'm dividing by 10 to the power 1, sorry, I'm going to move 1 place, but I'm moving it forward. So 3.7 divided by 10, that's 10 to the power 1, so I'm moving it 1 space forward. 0.9885 divided by 10, I'm dividing by 10 to the first power, so I'm moving it 1 space forward. 750 divided by 100, my decimal would be at the end. I'm dividing by 10 to the power 2, so I would be moving it 2 spaces forward. 2.947 divided by 100, I'm dividing by power 2, 10 to the power 2, so I'm moving 2 spaces forward. I would need to fill in with a 0. 6.3 divided by 100, I'm dividing by 10 to the power 2, so I move 2 spaces. I'd have to fill in with a 0. That is probably the shortcut that you learned when you were in elementary school. Now, what we're going to do is we're going to combine these two thoughts. We're going to combine what we learned from fact families with what we learned about multiplication and division by powers of 10. So let's take a look at a couple of these and see what we're going to do with them. I have 3.88 times 12 is equal to 46.56. This is a fact that someone has given me. Now, I know from my fact families that I could write it the other way. 12 times 3.88 is equal to 46.56. I also know that I can rewrite it as division. So I could say 46.56 divided by 12 is going to equal 3.88. I also know then that 46.56 divided by 3.88 is going to equal 12. So I now have my 4 facts from my fact family. But when I take a look at these problems at the bottom, I am no longer looking at just those facts. Parts of our statement have changed by a power of 10. That means I can use my multiplication and division by power of 10 in combination with my fact families. So 3.88 times 120. Well, I know that's the same as 3.88 times 12 times 10. 120 is the same as 12 times 10. Well, that means I can say 3.88 times 12 times 10. I already know what 3.88 times 12 is. That's 46.56. If I take 46.56 times 10, That means that I'm multiplying by 10 to the first power. I'm going to be shifting my decimal one place because my place values will change. And I have an answer. I didn't have to use a calculator to get it. All I had to do was know my fact families combined with my rules for multiplying and dividing by power of 10. Okay, so let's take a look at the next one. We've got 388 times 12. Well, I know that 388 is the same as 3.88 times 100. Okay, well, if I shift those around, I have 100 times 3.88 times 12. I did that using commutative property. Commutative property tells me that multiplication, I can change the order and still have the same answer. So 3.88 times 12, I know is 46.56. I still have 100 times that answer. From my power of 10 rules for multiplication and division, I know that I'm multiplying by 10 to the power 2, so I'm going to be shifting 2 place values. So that'll be 4,656. What about this one? I have 3.88 times 1.2. Well, gosh, I don't know what that is, but I know 1.2 is the same as 12 divided by 10. Twelve divided by 10 is 1.2. I just replaced it. So now I can look at this and say, well, 3.88 times 12 gives me an answer of 46.56. But then I'm dividing that result by 10. So what happens when you divide by 10? We shift place value. We're going to be moving our place value 1 place value towards the reciprocals. So that'll be 4.656. I did not have to use a calculator to come up with these answers. I was able to come up with these answers without using a calculator because I knew my fact families and I knew my rules for multiplication and division by power of 10. Okay, so let's take a look at these. Okay, I've got 46.56 divided by 120. Okay. All right, now these get a little trickier. When we're looking at 46.56 divided by 120, we can take this 120 and break the 120, break that 120 into a 12 times a 10. But you have to remember that you are dividing by both of them. The division uses the 12. The division is also going to the 10. So we're going to rewrite this as 46.56 divided by 12 divided by 10. Well, 46.56 divided by 12 we know is 3.88. If we take 3.88 and we divide it by 10, we get the correct answer by relocating our place values by a power of 10 towards the reciprocal direction. And we're there. So if I have 4,656 divided by 12, I know that 4,656 is the same as 46.56 times 100. Now we're not dividing by that. That is actually in front. I am going to be dividing by 12. But I do know that multiplication, I can shift the order. So I'm going to take 100 to the front. I'm going to do the 46.56 divided by 12. 46.56 divided by 12, I know is 3.88, but I'm still multiplying by 100. That means my final answer is 388.